Hello again. This is Tomo Wilkens. Thank you for joining part 3 for CPM Calculations. So I've been a scheduling professional since the late 1970s, and I was on the core team of the original scheduling practice standard for PMI. I hope by now you have had a chance to watch parts 1 and 2, which go into quite some detail on all the various intricacies of the CPM algorithm. In this part, we're going to address the critical path and to clear up potential confusion in what is meant by the critical path, period. Unfortunately, PMI's glossary does not help us much, as we will see. So we're going to talk about the critical path. What is it and where does it come from and why you should care. And so, as I mentioned a moment ago, it is often misunderstood and misrepresented, and I place the cause of that on the oversimplified definition of the critical path in PMI's PMBOK guide and the current edition of the scheduling practice standard. In the original version of the scheduling practice standard, we had the definition a little bit more explanatory, and by the end of this presentation, you will see what I mean. So this video will explain how a path becomes critical, what is meant by critical, and it suggests how PMI would serve the project management profession well by adopting the suggestion at the end of this video. PMI's definition of the critical path in both the scheduling practice standard and in the PMBOK guide, 6th edition and 7th edition, is the sequence of activities that represents the longest path through a project, which determines the shortest possible duration. So let us consider what this really means and what is wrong with this definition. In the scheduling profession, PMI's definition notwithstanding, a critical activity is one with zero or negative float or slack. A critical path is defined as any path or sequence of activities that has zero or negative float or slack. In scheduling software, activities are identified as critical by the amount of float they have. So the activities have a flag field called critical or criticality. And if the float or slack is zero or less, by default, that becomes the definition of critical, and those activities get the critical flag set. And that supports the definition given above. There is no requirement that such an activity or the path be located on the longest path of the project. So let us take a look. Here we have our familiar network that I used in parts 1 and 2. And if we look at the results of the forward pass, okay, we come up with A and B coming up to a total of 15 days. Then we have a 2-day lag. The green path, activity D finishes on day 8, but activity E can't start on day 9 because of the constraint. So it doesn't start until day 11. And now we can tell that C can start as early as day 16 because it bumps into B before it bumps into E. And then we have a finish date of 24, day 24, which is the end result of our forward pass. And these are known as the early dates. Now, if we look at the backward pass, we start calculating in reverse. So the latest finish by default for activity C is day 24. And I say by default because no project finish was established. And the computer has nothing to go by for the start of the backward pass, except the traditional default of starting backwards from the latest date of the forward pass. And therefore, this path here is going to have the same early and late dates, at least on the last activity. So as we then trace the start and finish dates back through the red path, we come up with 15 and 6 and 5 and 1 as before. And activity E can finish as late as day 17. which means it has to start as no later than day 15. D can then finish on day 14 and start on day 7. So we have now the late dates. Okay? And so if we look at the float, it is simply the late minus the early, and we see that we have 0 float on our longest path, and that adheres to the simplistic definition that PMI has in the PMBOK guide and the scheduling practice standard. The longest path is shown as critical because it has 0 float, but that's because we did not have a project finish date specified. So just hold on to your seat. We'll see what happens, okay? So this is a simple thing. Now, it turns out when you do project scheduling, you practically never have this situation where the longest path comes up with 0 float, because traditionally projects have a predefined end date. The client says, I want it by this date, or the sponsor or whoever. They set an end date. And when you assemble your network, you practically never ever come out with that same end date. That's just not how it works. Okay, so you have to refine your schedule until you can make it fit, but that's subject of another matter. All right, so let us take a look at what else can happen. Here we have the same network, but we have specified now a project finish date. So the client has said, I want this finished by day 22. So we do our forward pass as before, and we come up with day 24, but now the backward pass doesn't start counting on day 24, it starts counting on day 22, because that is the latest date for activity C to finish. Otherwise, it would go beyond the project finish date. So the late date for activity C then is 22 to finish and 16 to start. We account for the lag, and so B needs to finish by day 13, and A needs to finish by day 3, and it means it needs to start by day -1. Notice that I have extended the calendar here to go into before now, before day 1, to account for that, okay? So hold on to that for a moment. And then on the green path, right, E now has to finish no later than day 15, in which case it has to start by day 13, and then D has to finish by 12 and start by day 5. Okay. Now when we look at our float, we notice activity C has -2 days of float. It's same with activity B and activity A. You take late minus early, 22 minus 24, 13 minus 15, and so on. So we have 2 days negative float. Activity E has 2 days of float, positive, and activity D has 4 days of positive float. Again, the difference here is that the constraint pushes the early dates on activity E out, and it pushes them further to the right, closer to the late dates. So E does not have quite as much float as D has. So we now have still the longest path being a critical path. Okay, so we're still adhering to that definition. Okay, but let's take another look now. Suppose the client says, I need this project finished by day 26. So again, we do our forward pass and get our early dates. Here we are again on day 24. Now we start the backward pass calculating on day number 26, because the client says this is the latest date to finish this. So C has to finish by day 26, it has to start by day 20, and then as we go back through the rest of our red path, we come up with a late date of 17 for B and a finish, and a late finish on A of day 7. So activity E has to finish no later than day 19, right, the afternoon before C starts. And then D would finish by day 16 and start by day 9. So now if we look at the float, you notice that our longest path has positive float, 2 days positive. E has 6 days, and D has the additional 2 days because of this constraint. So D has 8 days. So now we have a situation here where we do not have a critical path. There isn't a single critical activity in this project. So to say that the longest path is the critical path is not correct in all situations. That is simply not true. Now, some people confuse the term criticality from a float standpoint with urgency or importance for some other reasons, mostly importance. This activity is critical to be done because it is very important, not, however, in the context of scheduling or time considerations. So now let us look at this situation. So again, we have a project finish of day 26. That's when the client wants it. And we do our forward pass calculation to get the early dates, just as before. Now the backward pass calculation starts on day 26. And then using the formula 26 minus duration 7 plus 1 gives us 20 as a late start date for activity C. Then accounting for the 2-day lag, activity B needs to finish by day 17 and start by day 8. And then A needs to finish no later than day 7 and start by day 3. Now on activity E, we have inserted a not later than finish constraint on activity E. So we're saying activity E needs to finish no later than day number 9. So the late finish date for activity E is no longer day 19, the day before activity C needs to start, but it is day 9, which comes from the not later than constraint. And so now activity E has a late start date of day 7, which gives D a late finish date of day 6 and a late start date of day -1. And again, you notice the extension of the calendar up on top to account for the negative time. So if we look at the float now, we see that on our longest path here, activities A, B, C, we have 2 days of float, late minus early, 26 minus 24, 17 minus 15, and 7 minus 5. Activity E has a float of -2. Late minus, late 9 minus the early of 11 gives us -2 days of float. And same for activity D, late minus early, 6 minus 8 gives us -2 days. So what we have now is a longest path that is not critical and has nothing to do with the with the criticality of the project. But we do instead have a critical path here that ends somewhere in the middle of the network. It has nothing to do with the longest path, but the criticality comes from this, in this case, not later than constraint. So here we have the longest path, which is not critical. It does determine the project finish, but it is not critical. So right here you can see that PMI's simplistic definition of the critical path is simply not correct in all situations. So what to do? Well, it is my suggestion that PMI adopt 2 separate definitions, one called critical path or critical activity, and go back to scheduling profession's use of the term critical if the float or slack is 0 or less, period, whether that's on the longest path or any other path. And a path or an activity is critical if it has 0 or less float or slack. The other term should be called the longest path. The longest path is the sequence of activities that determines the project completion. Okay? But it may not have anything to do with critical. So I hope that's been helpful. And as a slight footnote or epilogue, on every project that I have managed, we never had negative float unless it was due to conditions and lack of progress, etc. But from a planning standpoint, the longest path always had positive float, because I always ask the project team to come up with a plan that ends before the due date that we owed to the customer. And so our longest path always had positive float and I've never managed a project that came in late. So if you manage your float appropriately, you can get your project done. And I hope this explanation of the critical path has been helpful. And if you agree, send me some comments. Send some comments to PMI that you would really like to have the definition clarified. Thank you for watching and have a wonderful day.